Okay, Hannah, let's see if we got these right. You know, it's not so hard to do these when you have the answer right up here to look at, but anyway, hopefully these will help you out. Okay, so we have this quantity squared, and so it's just this times itself, right? So we have x plus 3y. Let me make sure this doesn't go too long. I'll cut it off after 10 minutes or so. Break these into separate videos. Plus 2, and that's just times itself, right? X plus 3y plus 2. And when you have some kind of complicated thing like this, it would be pretty easy to want to FOIL the whole thing, but when you have parentheses, let's just take these as individual terms, okay? So let's just leave this as a term. This is a term, this is a term, and this is a term. And let's just take the first term times the first term, and let's just write it. Leave it in the x plus 3y form. X plus 3y times x plus 3y. Then we go to the next term here, plus 2 outside of x plus 3y. I'll change colors for you, keep things interesting. In the spirit of con, right? Okay, next one times this one, next term times the first term, which is also at plus 2 times x plus 3y. We'll close those parentheses. And then that second term times the last one, 2 times 2 is plus 4. Okay, so from this point we can go ahead and multiply these things out and see what we have. X times x is x squared. X times 3y, we'll call it 3xy. 3y times x is another 3xy. And 3y times 3y is plus 9y squared. Okay, so we can add these things together and get x squared plus 6xy plus 9y squared. Okay, and then when we add these things together, we got 2 of these and 2 of these. So this is equal to 4 of these, right? X plus 3y. And we can go ahead and multiply this out, which would be plus 4x plus 12y. And then we have this positive 4 here. And is there any more like terms here? X squared is the only x squared. 6xy, there's no more xy, there's only one, this is the only y squared term. No other single x terms, no other single y terms, and this is the only number. So I think this is the final answer. Should we check it with our other answer to make sure? X squared plus 6xy plus 9y squared plus 4x plus 12y plus 4. And that is for the answer on the back of the book. There we go, number 33 worked. Okay, and we've done this one, f times g of x. So this is just x minus 2 times x squared plus x minus 3. And we'll take the first one times the first one, x cubed, first one times the next one, plus x squared, first one times the last one, minus 3x. And for us, okay, we'll start with the second one times the first one, so that's going to be a minus 2x squared. I'd like to write that underneath the like term, minus 2x squared. And then that second term times the next one is a minus 2x. Then our last one is a positive 6. We can write it all together. Bring these things down. X cubed minus 2x squared plus x squared is just a minus 1x squared or minus x squared. Minus 3 minus 2 is minus 5x plus 6. That should be what the answer book says. X cubed minus x squared minus 5x plus 6. And then on the way for the second part, if we want to evaluate that for 3, basically you just plug 3 right in for the x. And so 3 cubed minus 3 squared minus 5 times 3 plus 6. 3 times 3 is 9 times 3 is 27 minus 9 minus 15 plus 6. And I bet that equals 9. So I can extend the page. 27 minus 9 is, let's see, 18. 18 minus 15 is 3. 3 plus 6 is 9. Yes. Okay, let's try one more here. Divide. Okay, so when they're asking us to divide this, we're not doing synthetic division or long division or anything else, but you're just looking for like terms that are in every one of these terms. And let's just look at the numbers. We have a 2, an 8, a 12, an 8. They're all even numbers, and so we can start canceling. Right? 2 goes into 2 one time. 2 goes into 8, but you have to, it has to be in every single term in order for you to be able to cancel, right? 2 goes into 8 4 times. 2 goes into 12 6 times. 2 goes into 8 4 times. What about the x's? What is the very smallest power of x? Well, there's x to the first power right here, right? But we can cancel this x. I x it out, it doesn't let me good. Let's cancel it this way. X, okay, so it'll cancel with one of those and it'll just leave an x squared here. This will take this x squared away and just leave x to the first, or x, and it'll cancel that x all the way out. What about the y? The smallest y is y squared, so we can cancel that out. If we take y squared away from y cubed, it's just going to leave 1y, or y to the first power. Take away y squared from y to the fourth, it's just going to leave y squared. Y squared minus, or from y to the third is just going to equal y to the 1, or y. So what do we have left? Kind of a mess, but we have x squared in this term plus 4xy. I think that's what we have. xy plus 6y squared. All this is going to be over 4y. Okay, so when you have multiple terms in the numerator and the same denominator, you can rewrite this legally, and it is all individual fractions, right? You can write this as a fraction, you can write this as a fraction, and you can write this as a fraction. So you can x squared over 4y plus 4xy over 4y plus 6y squared over 4y. You're just splitting it up. Like if you started with this and you were going to add all these together, well, they have all the same denominator, so you can just add all the tops together and put it under the one denominator, and you would end up right here, right? Okay, so by doing this, some more things cancel. This 4 cancels with this 4, this y cancels with this y. This y cancels with one of these y, so it just leaves y to the first, or y. 2 goes into 4 2 times, 2 goes into 6 3 times. So let's see what we have now. X squared over 4y plus x plus 3 halves y. Is that what we need to have? X squared over 4y plus x plus 3y over 2. Bingo. I think we did it. Okay, I'm going to cut this one off. It should be about 10 minutes, and I'll pick it up with the next problem.